Your cloud audit feed just added 40 million events this month. The SIEM build doubled, the alert quality did not. Most of the new volume is read-only noise. List this, describe that, enumerate a page of settings. Buried inside are the events your analysts actually need: identity changes, failed sign-ins, key use, and policy edits. So the question is not, should cloud logs go to the SIEM? It is, which cloud logs earn hot storage? For this episode, Cloud Logs SIEM means a deliberate pipeline for cloud audit logs into your security information and event management platform. The SIEM is the hot analyst-facing system. It collects events, normalizes fields, correlates activity, raises alerts, and keeps enough history for fast investigation. A NIST-style way to frame it is simple. Collect the records needed to detect, analyze, and respond to security events. Not every record has equal value. Management events usually go in. They describe changes to accounts, roles, policies, networks, logging, and keys. Data events are selected more carefully because they can explode in volume. The goal is not fewer logs. The goal is the right logs in the right tier. Life before this strategy is messy. Teams turn on cloud audit collection, send everything to the SIEM, and feel safe for about a week. Then cost reports arrive. Search gets slower. Analysts drown in dashboards full of harmless list and describe calls. Detection engineers stop adding rules because every new query is expensive. Finance starts asking why security storage looks like a second cloud environment. The worst part is false confidence. You have a mountain of events, but you still might miss the one change that matters because it is buried under routine read-only activity. A keep versus drop policy fixes that. It protects detection quality, investigation speed, and budget at the same time. Build the filter in layers. First, keep management events by default. These are control plane records. Create, update, delete, attach, detach, enable, disable, rotate, assume, login, and policy changes. Second, explicitly keep security outcomes, authentication failures, access denied spikes, identity and access management changes, changes to logging, changes to network exposure, key creation, key deletion, and key usage by sensitive services. Third, curate data events. Keep reads or writes for high-value stores, secrets, key material, production backups, and regulated data. Do not blindly ingest every object read from every storage location. Fourth, drop or downroute read-only floods. List, describe, get status, get configuration, and pagination-heavy inventory calls. Fifth, route the full raw stream to cheap searchable storage, with retention that supports investigations and audits. A SOC had a noisy cloud audit source feeding the SIEM. Their top event names were all read-only inventory calls. They kept seeing millions of describe and list events from automation. We built a pruning table by event name. Keep, create user, delete user, attach policy, update role trust, create access key, delete access key, login failure, assume role failure, disable logging, update key policy, decrypt, and generate data key for sensitive key stores. Drop from hot SIEM, list users, list roles, describe instances, describe networks, get account summary, and routine get configuration calls. Those dropped events still went to cold searchable storage. The result was smaller daily ingest, faster identity searches, and clearer alerts when a real policy change happened. The strength of this approach is focus. Your SIEM stays sharp for questions analysts ask at 2 a.m. Who changed access? Who failed to authenticate? Who used a key? What policy moved? And what logging was touched? It also makes detection engineering easier because rules run against cleaner data. The limit is obvious. A filter can be wrong. If you drop an event from hot storage, an analyst may need to search cold storage during an investigation. That is acceptable only if cold search is reliable, documented, and fast enough. This strategy also does not replace endpoint logs, network telemetry, vulnerability data, or case management. It is log routing, not magic detection. Cloud audit logs are one signal in the defensive stack. Endpoint tools tell you what happened on hosts. Identity systems tell you about users and sessions. Network controls show connections. The SIEM brings those records together so the SOC can correlate them. For example, a failed cloud login followed by a new role assignment and a key use event should land in one investigation view. UEBA can help by learning normal patterns, such as which teams usually assume which roles, but UEBA still needs clean input. If the SIEM is packed with read-only floods, behavior analytics spend energy modeling noise. Good cloud log filtering helps every downstream tool. Start with a 30-day sample, not a permanent rule set. Pull the top event names by volume. Tag each one. Keep hot, route cold, or discuss. Build a starter keep list around identity changes, authentication failures, policy changes, logging changes, network exposure changes, key lifecycle, and key usage. Build a starter drop list around read-only list and describe events that are repeated by automation. Then test. Run recent investigations against the proposed hot set. Could analysts answer the questions they asked? If not, adjust. Document every decision with the reason, owner, and review date. After every incident, revisit the filter. Incidents reveal what your assumptions missed. Here is the recap. 1. Cloud logs belong in the SIEM, but not all at the same temperature. Keep high-value management events and selected data events hot. 2. Reduce noise by pruning read-only list, describe, and status floods from hot ingest, while preserving the raw stream in cheap searchable storage. 3. Treat the filter as a living control. Review it after incidents, architecture changes, and new detection work. If this helped, subscribe. A new Security Tools Decoded episode drops daily, and this channel also publishes the daily ranked CVE brief, so your team can track the vulnerabilities that matter first.